Hey all, so this is my demo for the CS2800 Fall 2024 TA application. So as you can see, I chose problem 33.3 because I like probability, and it's one of the few problems I found that doesn't have a bunch of disjoint parts like A through D. So I can hopefully get through this in the about 5 minute time allotment. Okay, anyways, so this problem states that we want to suppose that two fair-sided dice are rolled and S is the random variable representing their sum. Um, S has support 2 through 12, and the probability mass function is equal to this lovely expression up here, 6 minus the absolute value of S minus 7 over 36, where S is some element of this support set. And we want to find the expected value of S, the variance of S, and the standard deviation of S, the capital S, the random variable. So for the sake of time, I'm going to assume that the student knows everything preceding this lecture 33. So for us, that just means that they understand what the question is asking for, basically, and I can walk them through what exactly it's asking for. So beginning with this section one here, this expectation. So expectation is, I would think of it as just the mean. So if we were just rolling one die, for instance, the expectation here would be, well, if we roll the die, what's sort of like the average mean value going to be of this S, if S represents just one roll. Um, so with the notion that this is essentially a mean, I think the equation for this is a bit more straightforward. So we just want to say, well, given that we want to take every event's probability and find out, well, what's the expected value, you can see how this guy's going to be relevant here because each support is not equally likely. Like for instance, if there's just one die, each a fair die, as you typically assume, it'd just be 1/6 each way. Something like 8, for instance, is going to occur more frequently than 2, where there's only one way to get 2. So we're going to use this PMF and say, well, okay, we want to take the sum, obviously, that's a kind of horrible sigma, sum of every element S in this support set here, and we want to take the S itself times its weighting, essentially. So I'll just label that Fs of, or or sure. Um, so this is somewhat, uninteresting, just algebraic calculating it out. So I will cut to me having worked that out. All right, so welcome back. As you can see, I just worked it out. I wrote some of the idea here, but um, yeah, so you end up getting 7. So like the intuition here is just you roll 2 die, the average value you're going to get is 7. It's just the mean, and so this mass function, again, sort of assuming that the student has some intuition for what this actually describes, it's just acting as the weight on each of the values in the support to give you the mean. So I think that's so 7 is a reasonable value in that sense. I think if you roll 2 die, you would expect to get somewhere around 7 most of the time. Um, if they have some insight and they know that the average value for one die is 3.5, hopefully that's even more helpful or even more intuitive. Anyways, the next problem is asking for the variance of S. So variance is, again, sort of as the name suggests, a measure of how spread out your rolls are on average. The thing to keep in mind about variance is that it does this on a square system. So it's telling you how far out they are as on the basis of squares. Um, So yeah, the idea itself is intuitive. The way we're going to find this is maybe not so much, but the equation for variance is it's going to be the expected value, the squared value, the expected value of s squared um, minus the expected value of s then squared. So the way these are different is this one is taking what we already found and just squaring it, and this one is s squared is its own new random variable, essentially. So you would find it by this equation, but by, if I use a different color, by squaring it, then going through and doing this. So again, for time, I already did that, and I found this to be 329 over 6. And then this is just 7 squared, so it's 49. So that's your variance. So this is, I can't reset that mentally, but that seems, that's essentially on the square line how spread out are our data points. Where our data points are these S's. Um, so the intuition here would be, I roll 2 die. Sure, the average is 7, but how concentrated is it average? Because sometimes like maybe I roll like 300 sometimes, and it's sort of unclear how actually spread out things are. Obviously, I'm not rolling 300 here, but hopefully that explains the idea. And then third, standards deviation, a very similar idea, just a little more intuitive in that it's explaining the exact same thing as it's how spread out are random variables, but it does it not on a squared basis, but in whatever regular units we're using. So if we wanted to, so like in a more baseline statistics example, since it doesn't really make sense with die, if we wanted to measure height, for instance, um, or like length or whatever it may be, variance may be measuring it in meters squared, and standard deviation would be measuring it in meters. Um, Assuming that our baseline units are meters. So standard deviation is just explaining it sort of like in baseline terms, as you may know from exams. Standard deviation is in units of points, not point squared. It's kind of confusing. But anyways, I'm just sort of belaboring the point here. It's just going to be the variance, the square root of variance. So it's the square root of this term up here, 329 over 6 minus 49. So yeah, hopefully this was helpful.